Hey, good morning, everyone. Or good afternoon, sorry about that. We're going to start our last unit in Applied 30S, measurement. And this might be kind of a nice class to start or to end with because it doesn't require the graphing calculator or any special calculator simulator. So you can just use your regular scientific calculator, which might make your life a little easier. You can see that there's lots of lessons. There's 8 lessons, and some of the words might be familiar to you. We're going to talk about, there's that word linear, right? Meaning a straight line. Perimeter and area, I'm sure you've seen that and worked with that before. Irregular shapes, more perimeter and area, surface area and volume, and that continues on. Our last lesson's about scale. So if you have some design and measurement background in your past academic career, that will come in handy. This is also a unit in the grade 12 course, measurements, so keep that in mind. A lot of these concepts that we're learning in this last unit will be carried over into the grade 12. So lesson 1, we're going to talk about measuring and converting linear quantities. And there's that word line. That's where the word linear comes from, right? Or the word line. And that means, this basically means things that can be measured linearly, and that just means in one direction. Okay. Lots of things that we measure in our world have just one direction, right? Like our height, we're just measuring from the ground up. Way your heart rate, time, height, age, shoe size, distance. The common element to all of these measurements is that they can all be expressed as a single number. You don't need more than one number to describe most things that we measure. Anything that can be measured using a single numeric value is called a linear quantity or a linear measurement. We're only measuring in one dimension. They are called linear because you can measure them in a straight line. Okay, this might be important to remember. Anything that can be measured using a single numeric value is linear. They're measured in a straight line, one direction. Some measurements, like your height, you would find with a ruler, or you could place the measurement on a number line to compare it to other measurements. Linear quantities are also called one-dimensional, and that's what I was saying earlier. They're measured in one direction. Their only dimension is the single measurement needed to express that quantity. Your height, for example, it might be 172 centimeters. The only dimension of this measure is the height itself. So we're going to learn how to take a measurement and how to convert that measurement to alternate units of measurement. Example 1, measurement using a ruler. I'm sure we've all done this before. Use the ruler provided below to measure the length of the bird from the end of the tail to the tip of the beak. Okay, so they've got this picture of a little bird. So we've got the end of the tail to the tip of the beak, and if I notice that this ruler measures in centimeters or in inches. So let's take a look what it measures in centimeters. So from 0 to, I guess we would say, this is 4.5, 4.6, 4.7, 4.7 centimeters, correct? Or, I don't know, inches would be a little harder, right? It's between these two notches, so I think centimeters would be a better measurement. Okay, so that's it. That's just measuring on a ruler. Sometimes it's hard to measure things on a ruler. For example, the distance around a circle is very hard to measure with a ruler, but we'll figure out other ways to do that. Measuring with a ruler. Let's take a look at the next page. When you are recording writing down a measurement, you need to be sure to state the units that you use when measuring. You do this so that any person reading your measurement knows what unit you used. If you just wrote 4.7, the person reading might think you meant inches or centimeters, but or miles or whatever, but you have to be able to use, or make sure you record your measurements so that people know what you're talking about. In this unit, it's very important that you include units for all your answers. I think we've been sort of stressing that throughout this course, that you should be using units with all your answers. And we always stress if your answer is in dollars, you should include the dollar sign, etc. Okay, let's just talk about tools and units. With your teacher, examine each stated quantity, state at least one possible measuring tool and 2 units of measure for that quantity. Well, it's kind of hard to do without a class brainstorming, so I'm just going to brainstorm on my own. How would you, the tool that you would use to measure a person's weight, let's do the tool first. I think I would just use a scale, right? And units, we could use either kilograms or pounds. A person's age, honestly, I don't know what kind of measuring tool we would use. And I think I would just use years. I honestly don't know what I would use to measure a person's age with, so I'm just going to use that for the length of a movie. I guess we could use time, right? And I could use hours or minutes. I guess I could use years or months. Sometimes we measure babies' age in months. The length of a fish, I could use a ruler again. You know what? I'm going to go back, and I guess this I would use, I guess I'm just going to say time as a tool. It's kind of, sorry. If I use time as a tool for length of a movie, I can use it for a person's age. Don't know if I really classify. Okay, I'm hoping so length of a fish, ruler, and I could use centimeters or inches. Distance between 2 cities, I could use a map. I could use kilometers or miles. The weight of a bag of sunflower seeds, again, I could use a scale, and I could use probably grams or ounces. I'm going to talk about grams, ounces, kilogram, miles in the next page. And then temperature outside, of course, I could use a thermometer. And I could use Celsius or Fahrenheit. Okay. All right. So that's just to kind of get you familiar with what we're talking about here, units. And now we're going to talk about something very important, metric versus imperial. So metric versus imperial. This is quite a long piece of text, and you can read it on your own. And I'm going to summarize this by saying that almost the entire world uses the metric system, including Canada, because it's easy and it's universal and it makes sense and it's not confusing at all. And it's standardized. The United States is the only major company or major country using imperial system, so that's why it's still around, to be honest. I'll let you read that on your own. Canada, since we're so close to the US, we share so many things. We have to have a knowledge of the imperial system. If the United States wasn't our neighbor, I don't think we would really have that much to do with the imperial system. But because so many of our day-to-day objects use the imperial system, for example, when we go to the store, we still can see things sold or talked about in square feet. And lots of our tools are still use imperial measurement, not only for cars, but for homes and just your do-it-yourself tools. So we have to have a knowledge of both. But if the United States wasn't so close and so tied to us economically, we would just be dealing in the metric system. So why does this matter to you? The result of this measurement system is that you have to be familiar with both systems, metric and imperial, just because you're Canadian, to be honest. However, any question that you work on will use units from one system or the other. You will never have to convert from metric to imperial in this class. You will only be converting within the metric system or within the imperial system, if that makes sense. So if the question is given to you in metric, you might have to convert between metric units. If the question gives you imperial, you might have to convert inside between imperial units, but not from one system to another. Now, in applied math, you always get, whether you're in online classes or not, but you'll always get your formula sheets to use or to record on your own personal formula sheets. You never have to memorize any of this. But let's just look at some common distance conversions. So the metric system, 1 centimeter is equal to 10 millimeters, 1 meter, 100 centimeters, 1 kilometer, 1,000 meters. Once again, you always have your charts in front of you, but you probably might know some of these. And for imperial, this is why it's just such an odd and difficult system, because these numbers don't have any meaning or bearing, or there's no consistency. 1 foot is 12 inches, a yard is 3 feet, 1 mile is 5,280 feet, or 1,760 yards. Like, it's just really off. And there's reasons for that. And you can read a little bit about the history of that if you're really interested. For weight, you can see everything. The metric system is a base 10 measurement, so it's really easy to use. 1 gram is 1,000 milligrams, a kilogram, 1,000 grams, 1 pound, 16 ounces. Now, time is something that some people struggle with, but you should know this is kind of this is something that is neither metric or imperial. This is just standard using time worldwide. So you should know that 60 seconds make up a minute, 60 minutes make up an hour. There's 24 hours in a day, 7 days in a week, 12 months in a year, 52 weeks in a year, and 365 days in a year. Okay, those are things that you should sort of know, but you always have them recorded. Okay, let's do some converting. Today I'm going to kind of do a lot. And then I'll make tomorrow's class a bit of a word class. In order to convert a measurement from one unit to another, you need to know the conversion factor, and you need a consistent method. We're going to talk about 2 methods. Method 1 is using a proportion, and this is really foolproof. We're going to convert 2.7 meters to centimeters. Okay, so when I see meters to centimeters, I am immediately thinking, okay, I'm going to go to my previous page. I won't keep flipping back and forth, but if you look at your previous chart, look to see where meters and centimeters are joined. And here it tells me that 1 meter is 100 centimeters. Okay, so that's my conversion that I write down. 1 meter converts to 100 centimeters. Okay, that's my conversion factor. Write it as a fraction. Make sure you know which unit is which. So include your units, include your labels. 1 meter is 100 centimeters. Then you're going to place an equal sign and then a blank fraction bar to the right of your fraction. Now, look at the question and look what the question asked you to do. They said convert 2.7 meters to centimeters. They gave you 2.7 meters. So because you put your meters on the top, that's where your 2.7 goes, because it's also meters. So that's recorded here. I have 2.7 meters. I want to convert that. I want to find the appropriate number of centimeters. So centimeters should be on the bottom of your fraction, right? Because that's where it was on your first fraction. But this is the one I don't know I'm solving for, so I call that x. And then we do this is called a cross-multiply technique, proportion or cross-multiply technique. I think I called it cross-multiply earlier on in the course. We did a little bit of this work when we were doing polynomials. So in a cross-multiply, this number divided by this number has to equal this number divided by this number. The technique we use, I don't know if you realize this, but I'm just going to show you something else. That in a cross multiply, I'm going to give you an example. Everyone knows that 1/2 equals 5 out of 10, right? They're the same fraction. That means that 1 divided by 2 equals 5 divided by 10. But what many people also might not know is that when we cross the numbers that are diagonal to one another, 1 times 10 also has to equal 2 times 5. So because the diagonal numbers also equal each other when multiplied, that's the technique I'm using in this cross multiplication process. So that means that 1 times x has to equal 2.7 times 100. Okay, that's what's happening here. X times 1, or 1 times x, must equal 100 times 2.7. Okay? So the 1 is really easy to deal with, but if you just think about this for a sec, if I want to solve for x, I'm using some algebra here, x must equal then 100 times 2.7, and to get x by himself, I have to just divide this 1 out. Okay, so that's what I have to do to the right-hand side. So my unknown number is going to equal 100 times 2.7 divided by 1, and that's how we get this 2,700. Okay, so when I punch all that into my calculator, I get 2,700. Now the shortcut, if you look at these three numbers, how they're connected, the shortcut is I take the two diagonal numbers that I know and I multiply them together. And then I divide out the diagonal number that doesn't have a partner. And that's how we solve a cross multiply or a proportion method. Now, I guess I have to make sure that I was solving for centimeters. So you just have to record your centimeters there. Okay, so that's the proportion method. Now, there is another method. The shortcut method, it's really quick. But there's some, it depends on two factors. Your conversion factor must be written in the form. So you have to write the larger unit first. So in this case, it would be meters equals centimeters. And you need to figure out whether to multiply or divide. To figure out whether you need to multiply or divide, you can use the following. If I'm going from larger to smaller, if I'm moving this way, I multiply. If I'm moving this way, I divide. So for our question, we were trying to convert from 1 meter to centimeters, so we're multiplying by 100. So we took our, whoops, that's very messy, sorry. We were going from meters to centimeters, so we're multiplying. So we just take our meters and we multiply by 100. It's a little more intuitive. It actually, I think, even though it's simple, there's a lot to it. So I'm going to stick to the, I'll do a couple with conversion, and then maybe I'll do a couple with the quick way, okay? So I guess for the quick way, you have to always remember you're going larger to smaller. And the only reason you're doing this is so you can keep using multiply this way and then divide this way. Okay, let's try a couple from example 3. Perform each of the following unit conversions using both the proportion and the shortcut method. So convert 5.9 feet to inches. All right. So I'll flip back. And I have to look how inches and feet are connected. 1 foot. I'm just going to erase this for a sec. 1 foot equates to 12 inches. Put my equal sign. I'm converting the feet, so the feet go on the top, and this is my X. So the cross multiply way is, I think it's pretty straightforward. I take the two numbers that meet on the diagonal, I multiply and divide by this one. So X equals 12 times 5.9 divided by 1. So my answer is going to be 70.8 inches. Okay, so if I use the quick way, the larger unit is feet, right? So I'm going from feet to inches, so it's in the proper form. So I'm going to multiply by 12. So it's just going to be 5.9 times 12. And again, that gives me 70.8 inches. Right? That seems pretty foolproof. But the cross multiply gives you a method that always, it's a little clearer to see your steps, I think. So let's convert now. They're getting me to do millimeters to centimeters. This gets a little tougher, right? Millimeters to centimeters. Well, this is the connection. 1 centimeter equals 10 millimeters. Okay, I just got that from the chart. So they gave me 2980. Millimeters has to go on the bottom. My X is on the top. It doesn't matter where your X ends up, top or bottom. The technique is the same. I multiply the diagonal numbers and I divide by the leftover. So I get 1 times 2980 divided by 10. And that's going to give me 29.8 centimeters. And let's do the quick way now. So the quick way is I have to write my larger first. So centimeters is larger than millimeters. Okay, so I have 2980 millimeters and I want to convert to centimeters. So I'm going to be doing a divide by. So it's divided by 10. Divided by 10, because that's my factor. So once again, I get 29.8 centimeters. So whatever way you find easier. So maybe I'll do a couple. I'm going to do these two using cross multiply, and then these two I'll use the quick way. So I've got 88 ounces. The short unit version for ounces is 0 Z. And I'm going to convert to pounds. I kind of did that backwards, didn't I? I did it again. Oh well. I know that 16 ounces equals 1 pound. Okay. So this is my X. I guess I didn't need to write out the. Okay, 16 ounces equates to 1 pound. I've got 88 ounces and I don't know how many pounds that equals. So once again, I multiply the diagonal numbers and I divide by the leftover to give me X. All right, so I get 5.5 pounds. And believe it or not, LBS is the unit, the short unit, if you want to just do it short, version of pounds. All right, let's do the next one, minutes to hours. Okay, well, I know that 60 minutes equals 1 hour. Okay, that's the standard conversion. So I want to convert 230 minutes. Minutes goes on the top because that's what I put on the top here. And my x. So I'm going to multiply and then divide out. So 1 times 230 divided by 16. And I get 14 point, I'm going to have to round 14 hours. All right, I'm going to do the next two the shortcut way. So I'm converting kilometers to meters. I'm just looking at my chart so I don't make any mistakes. 1 kilometer equals 1,000 meters. Okay, so equals 1,000 meters. All right, so I've got 4.8 kilometers. I'm converting to meters. So I'm moving this way. So I'm going to multiply by 1,000. So 4.8 kilometers equals 4,800 meters. And finally, okay, they've got this double star. That usually means something's, oops, that means something's pretty tough. So let's see. Milligrams to kilograms. When I look at my chart, I don't have a direct conversion from milligrams to kilograms. So what I could do is I can convert to grams. There's other ways you can do this. We can convert to grams first, then convert to milligrams. Pardon me, kilograms. If you're really advanced, you could figure out the multiplier to go straight from milligram to kilogram, but I'm going to do this in baby steps. So I'm going to go, I know that 1 gram equals 1,000 milligrams. Okay, so I have 39,500 milligrams. I'm converting grams. So I'm moving backwards, so I'm dividing by 1,000. So that gives me 39.5 grams. Okay, we could do it that way. Okay, so now let's convert grams to, now convert grams to kilograms. So if I look at my chart again, 1 kilogram equals 1,000 grams. And I have 39.5 grams. Again, I'm moving backwards, so I'm dividing by. So I'm going to divide by 1,000 again. And I get 39.5 divided by 1,000. And I get an answer of 0.395 kilograms. Or if I was rounding to 2 decimals, 0.4 kilograms. Okay. And I'd probably have to do that 2-step process if I was doing the cross multiply again, because I wasn't given a straight conversion from milligrams to kilograms. Although you could probably Google that. All right, let's do this double star one again. Convert 2.3 years into minutes. I think same thing, right? Well, I guess what are we going to do first? We could convert. Let's take 2.3 years. Let's do, how many days would that be? Let's figure out days. 1 year is 365 days. So let's figure out how many days 2.3 is. So again, I'm just multiplying and dividing. So I get 2.3 years equals 839.5 days. And if I think about it, one day has 24 hours. So if I multiply by 24 hours, I'll get the number of hours. And if I multiply by 60 minutes, I'll get the number of minutes. Oops. And that's all they wanted me to do, right? They just wanted me to figure out how many minutes it is. So I'm converting this into hours and this into minutes. And that should give me the number of minutes. So we get 1208880 minutes. Okay, so those last two are just kind of like little, kind of interesting little tag-ons to see if you could just take it even further. Those aren't your typical, though, questions. All right, let's see what's on the next page. So the next page is performing conversions with non-standard. So we're going to leave that for tomorrow or the next day. And I'm just going to get you to start on, maybe try number 1 and 2 for homework, just some conversions. I'll give you some work time tomorrow. I'd really love to know if anyone's watching videos. Send me an email. Send me some questions or whatever I could do to help. And let me know what else you would like to do during class time, how I can make your life a little easier. All right, so I'm going to end today. I think we've talked quite a long time, or I've talked a long time, so I will see you tomorrow during the work class.